Welcome to our continuing discussion, monologue, call it what you will, on trigonometric equations. This is pretty much the capstone, the punchline, where everything comes together. In this couple of videos and also in what you'll be doing in class, you will start to put everything you can together with regards to trigonometric equations, trigonometric identities, any algebra techniques you have access to. You are going to bring it all together and see if we cannot solve as many equations as possible. If we can't find as many solutions to as many equations as we can. So that's what we're going to be doing here for these next couple of videos. Specifically, I have a few strategies I want to outline in the next couple of videos. First, looking at object-oriented solutions. I'll get into that here right away. And then we'll use some trig identities and then some general algebra techniques. So here we go. First thing I want to look at is the solutions to the trigonometric equation 4 tangent 4 theta equaling 4 root 3. Now, you could expand this. You could use a double angle formula twice, right? You could turn tangent of 4 theta into some expression in tangents of 2 theta, and then for each of those tangents of 2 theta, turn those into finally expressions in tangent of theta, and then you would have a giant mess on your hands to simplify, reduce down, and finally solve for tangent theta, and then finally solve for theta. Let's not do that. You see, we don't have to. We don't always have to use trigonometric identities or formulas when we don't have to. We can just be smart about things, keep simple things simple, and take things in stride. So something like this, I don't need to reduce this down to tangent of theta. I can just solve for tangent of 4 theta, and then solve for 4 theta, and then finally solve for theta. So that's what I did here. I solved for tangent first. So I got down to tangent of 4 theta equals the square root of 3. Applied the arctangent to each side. And I've got now 4 theta is equal to pi over 3. That is one specific solution. Of course, it's not a solution for theta, it's a solution for 4 theta. But I don't think it's going to take too much to go from here to theta equals something. That said, there is a little bit you have to keep track of, right? Our general solution for 4 theta is going to be pi over 3 plus k pi. So that means our general solutions for theta is going to be 1/4 of that, right? I've got 4 theta equals all this, so I divide through by 4, and I'm going to get pi over 12 plus k pi over 4. So this is going to be, see, that's 15 degrees, and this is k 45 degrees. So if you'd like, you can say it's everything coterminal with 15 degrees plus 45 degrees all the way around. And that would also be true. And you can check these. These will all satisfy our original equation here. Because take any of these angles, quadruple it, the tangent of that is going to be the square root of 3. Alright, so not so bad, right? Not so bad. Just solve for the appropriate expression when you can, and then do the appropriate inverse trig function, and go from there. Of course, you can't always do this, but when you can, by all means do. Alright, so here's another example. We're getting into more algebra techniques now, because I don't have just one expression to solve for anymore. I'm a little out of my depth in that regard. Also, I can think back to what we did a couple videos ago, where I had 2 sine squared theta plus sine theta equaling 1. I don't have that here, but if I did have something like this, I'd be in pretty good shape. Right? This would be a quadratic, right? 2u squared plus u minus 1 equals 0. Solve for u, solve for sine theta, and then finally solve for theta. But I don't have 2 sine squared, I've got 2 cosine squared. Luckily for us, though, there is an expression and a formula I can use to quickly transform cosine squared into something looking a lot more like sine squared. Right? Sine squared plus cosine squared equals 1, therefore cosine squared is equal to 1 minus sine squared. So let's substitute that in and see what we get. A little bit of algebra ensues, right? This becomes 2 cosine squared plus sine equals 1. So do the distribution there. I got 2 minus sine squared plus sine equaling 1. Clean everything up. 1 plus sine minus 2 sine squared. 2 numbers multiplying to negative 2, adding to positive 1. That's negative 1, positive 2. So I've got now, our original equation was satisfied whenever this equation is satisfied, which of course happens when either factor equals 0. So either sine of theta has to equal 1, or it has to equal negative a half. So applying your arcsine function, you'll realize that a solution to this would be pi over 2 for this one, and negative pi over 6 for this one. Of course, you have to go from there to your general solutions, right? The only time on the unit circle you're going to have sine of 1 is at pi over 2, so that's pi over 2 plus 2k pi. But there's two places on the unit circle where you're going to have sine of that angle equaling negative a half. Negative pi over 6, right, 11 pi over 6, and also 7 pi over 6. So your general solutions is each of those plus 2k pi. Although you could also write that as everything coterminal 90 degrees, 210 degrees, and 330. Both of those are good. And so that's really going to be our job here in the next couple of days, as long as we're working with general trigonometric equations. We're going to have to ask ourselves, what do we need to do in order to find a way to factor it down? Or as we did before, right, solve directly for the appropriate trigonometric function and then finally solve for the final value we want, right? Finally solve for theta or whatever variable we're working with. That's going to be our job. And so I'll show just a few more techniques, and then that well of tricks, that bag of tricks will have been fully dumped out for you. There's really not that much as far as procedure is concerned. There's not that much as far as memorization is concerned. It is really just looking at what you've got, right? Looking at what you need to get to, looking at what you can use, right? Looking at your tools, looking at your bag of tricks, whatever you want to call it, and finally discovering what the right thing to use is going to be for your situation. And really, most of that is going to come through with practice and experience. And so there's really not much else to say. I've got one more video here that I'm going to make, and you're going to watch that pretty immediately, I imagine. And that's going to be just a couple more of techniques, and we will be set. So I'll see you then.